1 is actually not a bad place to start, even though this will not be on your test. Every topic on here is related to something that's going to be on your test. So what we're going to work with in Chapter 7, and I will tell you that this is more difficult than Unit 1. Chapter 7 is one of the harder chapters in this class. We're going to work with rational expressions. And a rational expression is an expression that can be written as p divided by q of two polynomials as long as q isn't 0. Why can't q be 0? If I have this fraction, p over q, why couldn't q be 0? You can't divide by 0. That fraction's undefined. That ties right back to what we just finished up in Chapter 8. You can't have the denominator of a fraction be 0. So some of what we're going to be working with, a rational expression, could be something as simple as like 2x over 3. Or we could get something like x plus 1 over x minus 2. It's a fraction. Rational means fraction. And it's just made up of polynomials. And it could be something like x squared plus 4x plus 10 over x squared minus 9. All of those are examples of rational expressions. Just a fraction that's made up of polynomials. And what we're going to learn in Chapter 7 is we're going to talk about when they're undefined, which we already know how to do. We're going to simplify them, multiply them, divide them, add, subtract them, solve equations that have rational expressions in them, and word problems, application problems with rational expressions. So we're going to do a lot with rational expressions. That's all of Chapter 7. It is its own unit. So we just said it. Rational expressions are undefined when the denominator equals 0. Is that divide by 0? Congratulations, your math just destroyed a city. This is a very important concept. It finished out 8.3. When we looked at domains, we saw a fraction. We were worried that the denominator couldn't be 0. That's the same topic right here. What we're going to start with in problems in Chapter 7 is you need to tell me when a rational expression is undefined. Now this is actually like a watered down version of finding the domain. So what's going to be on your test is like the first question on your drill today. You have to use an interval to write the domain to find what x value you can't have and cut it out. In Chapter 7, the question is, find all numbers for which each rational expression is undefined. If it's defined for all real numbers, so state. So notice, all of these are fractions. I have the same trouble area with my fractions. Where do I have trouble with fractions? What part of the fraction gives me potential trouble? The denominator, the variable in the denominator is going to give me a potential trouble area. So this goes right back to what we did in 8.3. You just don't have to set up the intervals in these problems. It's a little bit less work, actually. So I know that my fractions have a trouble area, just like in 8.3, in the denominator. And what value can't the denominator be? 0. So just like in 8.3, I'm just going to take that denominator, set it equal to 0. I want to know what value of x makes that undefined. And that's undefined when the denominator is 0. Now I need to solve for x, so I'm going to divide both sides by 5. So I get x equals 0. So this rational expression is undefined when x equals 0. Just set your denominator equal to 0 and solve. And this is not asking you for the domain. It's not asking you for intervals. You just have to list the value. So that's the only real difference between this question and the question of what's the domain. Domain, you then set up the intervals. This just asks for what values is undefined when x equals 0. So for B, I have 5x plus 4 over 4x minus 5x plus 2. I want to know when that fraction's undefined. Cities implode, houses implode, when something happens to the denominator. This is undefined when your denominator equals 0. It's always the denominator. I never care about the numerator, ever. Now this one looks a little bit different. I've got factors and they're equal to 0. This actually goes back, again, this is great tie-in. This goes right back to 6.6. How do I solve that now? Set the individual factors equal to 0. So if you have factors and they're equal to 0, someone did all the setup for you. Just take each factor and set it equal to 0. and solve them individually. This first factor is a two-step equation. I'm going to start by adding 5 to both sides. So I have 4x equals 5, and then divide both sides by 4. So that idea right there is something that you'll see on Friday. So we have x is equal to 5/4 is one answer. And what's my other answer? X equals -2. That's a one step. Just subtract 2. And the other way you could write that answer if you want, it's a set. Since they're both x's, you could use the squiggly brackets if that's how you like to write the answer. One or the other. You don't need both. So any questions so far on how we're finding these values, why we're finding these values, or on the solving steps? Because the solving steps are something that are on your test. Setting factors equal to 0. 6.6. All right, C. When I'm looking at a fraction, where's the trouble area? The bottom, in the denominator. So I'm looking at my denominator. How is this different than, say, A? Doesn't have a variable. Well, if it doesn't have a variable, what happens if we say 4 equals 0? Do I have anything to solve for? Is that true? No. So really, there's no trouble here because there's no variable. The only time I'm going to have something to solve, something that could potentially give me 0, is if this has a variable. This can't be 0, it's 4. At best, we might be able to simplify it, but it's never going to turn into a 0. The most it could turn into would be, maybe we could get it down to a 1. But if there's no variable in the denominator, then there's no trouble area. So this is defined. If you go back to your directions, it tells you what to say. Defined for all real numbers. And in math, you can save yourself a little writing. Math people tend to write as little as possible. We have a symbol for real numbers. It looks like a capital R, except you start with 2 lines instead of 1. So it's a capital R, but it starts with 2 vertical lines instead of 1. That's the math symbol for real numbers. So because there's no variable in the denominator here, there's no trouble area, so it's defined for all real numbers. And you don't even have to memorize that wording. It's in the directions. It says, if it's defined for all real numbers, so state. So I stated it here. Now in D, am I going to have somewhere giving me trouble? Yes. Why? It's not a square root. Square roots are actually our unit 3. That's one of those little boxies. Square has a squared, but it's not just the fact that it has a squared. It's the fact that it has variables. Variables in the denominator. So I see my denominator. Again, never ever care about the numerator. They can be anything. Denominator can't be 0 on a fraction. So I'm going to see when does this equal 0, and that's going to tell me what x values I can't have. Now, on your test, make sure you set up the intervals. It's different questions. It's the same concept. Denominator equals 0. On your test, make sure you set up the intervals. And it will say in the directions on your test, use intervals. So you'll know. Anna. Yeah. What type of equation is this? This actually will, this idea, starting from this point right here, will be on your test. What kind of equation is this? Quadratic. Why is it quadratic, Christy? It's got an x squared. If it has an x squared, it is quadratic. And this is in 6.6. You actually get quite a bit of review today. 2 steps have to happen for me to solve a quadratic. What's the first one? Well, that's when we get down to factoring. But when you have a quadratic, so it's got x squared in it, what's the first thing you have to check in order to solve it? Equal to 0. Which for these particular problems, that's always true. On your test, it might not be equal to 0. So the first thing you have to do is move over some terms so it's equal to 0. And there's a problem like that on your review. You can watch it again if you want. That video is available on Blackboard. And after it's equal to 0, Alicia, what do I do? Yeah, use the AC method. And just generally we're going to say we factor it. Because it needs to look like this problem right here. Just in this problem, someone did all the factoring work for us. But for D, we have to factor. So I've got 3 terms, no GCF, which tells me AC method. So I'm going to go with A equals 1, B equals 9, and C equals 8. So AC is 1 times 8, which is still 8, and B equals 9. So I'm looking for 2 numbers that multiply to 8 and at the same time add to 9. 8 and 1. Do I have to go through grouping? No, why not? A is equal to 1. I wouldn't. Let me just look at our next examples. You don't think I'm going to... Yeah, okay. I'll go through full grouping on this one, and then for the rest of the notes, I'll use the shortcut. You'll want to use the shortcut a lot in Unit 2. It's going to save you a lot of time. But let's just go through full grouping. Good review for your test. So when I need to go through full grouping with the AC method, what am I doing with the pair of numbers? Napoleon, what do you got? Where do they go? In the middle. The numbers go in the middle. So I keep the x squared. In place of the 9x, I have 8x plus 1x. You don't necessarily have to put the 1. And keep the plus 8. So I just took the 9x and I replaced it with 8x plus 1x. And again, you don't necessarily have to do this for this problem. You could use the shortcut. And then once I have my 4 terms, I'm going to put my 0 off to the side just so I remember. I split them in half, and I factor a GCF from my group, which in the first group is x. What's the GCF in my second group? X plus 8. 1. Well, we do want to put that in there so that we can build our final factors. So this was if you wanted to do the full AC method. Again, we could just go right to this answer of factors right here using our 8 and 1, since A was 1 in the problem. Now, on your test, if a problem says factor, that's where you cut it off. That's where you stop. But we're not factoring here. We're solving. So this is 6.6, that one extra step. Just take each factor and set it equal to 0. So x plus 8 equals 0. X plus 1 equals 0. So I get x equals negative 8 and negative 1. Or you could do your set, negative 8, negative 1. Now, in this particular problem, you could skip all this work right here. You could just go right to x plus 8, x plus 1, since a equaled 1 up top. But that's your full AC method. You've got to do something other than the shortcut if a is not 1. That's an option. If you have another way to do it, that's fine. But that's an option. So when you're asked when a rational expression is undefined, when we're looking at fractions, we know denominators can't be 0. Set it equal to 0 and solve. In Chapter 8, what's going to be on your test, the problem's going to ask you for the domain. The problem's going to look the same. It's going to say write using interval notation. So you do this process, and then you set up your intervals. Dennis. No, if you're not good with the brackets, just write x equals. It's one or the other. You don't put both of those. Yeah, one or the other. Any other questions? All right, so that's the first topic in 7.1. The second topic is going to be simplifying rational expressions. And this is why when we looked at f divided by g of x, I said just leave it. You can't simplify it. We'll find out why. Now we're going to find out why. So first thing we do is complete each sentence. With rational expressions, before you simplify, you factor. This is why Chapter 6 is so important going forward. With rational expressions, before you multiply, you factor. And with rational expressions, before you divide, you flip the second fraction. We're dividing fractions. And then what do you think you do? And factor. This is why I said factoring doesn't go away. All of Unit 2 is built on factoring. What it's going to be, for simplify, the problems are going to be factor, factor. You got to factor the numerator, factor the denominator. For multiply problems, it could be factor, 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 factor. Numerator and denominator for two fractions, or more even. We only get up to 2. So you got to be comfortable with your factoring. So we'll get a little bit of factoring review as we go through simplifying. So what we're looking to do is we're looking to factor numerator and denominator, and then we can cancel any common factors. And we're going to get this idea of opposites as well, which is the same two terms reverse subtracted. We can cancel, but not perfectly. So this goes on the same idea of, let's say you wanted to simplify the fraction 4/6. How do you simplify 4/6? Y'all know what you get, but what do you, so here's some 2/3. Well, how do you get 2/3? Divide by 2. What you're doing, and you don't think about it, this isn't probably how you've done it in a while, if ever. What you're looking for is 4 is 2 times 2, 6 is 2 times 3. They have a common factor. You saw I can divide them both by 2. So what you're really doing is you're just canceling out or dividing out the 2 that occurs in the numerator and denominator, and that's how you get your 2/3. And we're going to do the same thing here, except we're going to have factors. Polynomial factors, not just numerical factors. So our first one actually is monomials. It's a little bit easier. So I have 14y to the third over 21y. So these are monomials, which means I can just simplify it. So I want to start by simplifying the 14 over 21. So what can I divide out of both 14 and 21? 7. So 14 divided by, this goes back to your basic math. Divided by 7 is 2. 21 divided by 7 is 3. How about the y's? Those can be a little bit more difficult to cancel, but we've worked with this in our factoring. I get y squared. How do you get that, Napoleon? You cancel out one y. So I believe your book actually breaks it up and does something like y to the third is y squared times y to the first. And then they cancel them. But our just rule, yeah. Yeah, that's the rule. Yeah. I think your book writes it out. I don't need you to write it out. The rule is when you divide, you just subtract the exponents, which tells you that's y squared. Is the y squared going to be in the numerator or the denominator? Numerator. It's always wherever you started with more. So it's not always the numerator, but if you subtract and you look at, okay, where did I have more y's, more in the numerator? That ends in the numerator. So I have 2y squared in my numerator and that 3 left in my denominator. So when you divide and you have monomials, just subtract the exponents. Now for B, the common mistake, the thing you probably want to do is just maybe work with, say, the 3 and the 9 and just leave the 6x where it is. But you can't cancel terms. You can't cancel individual terms. We need to cancel factors. So what we want to do is factor the numerator if you can, factor the denominator if you can. Well, the numerator 3, there's nothing I can do to factor 3, but how can I factor 6x minus 9? What do you say, Tiffany? Factor out of 3. GCF. Whenever you're looking to factor, first thing you should always look for is a greatest common factor. So I can factor out a 3, which means down here I'm dividing these by 3, so I have 2x minus 3. And now you'll see this problem is made up of factors, things that are multiplied together. And since this 3 is now a factor, it's multiplied, I can cancel it. So I could cancel the 3's now because they're part of factors, not terms. What would I leave in my numerator if it cancels out completely? Can't just leave it kind of floating there. 1. 3 divided by 3 is 1. Who asked that? What do you mean just write it 2x minus 3? No, it has to be 1 over, because it's the difference between, like, if I have $4 versus if I have 1/4 of a dollar, which would be a quarter. So where that ends is important. So since it was in the denominator here, it's got to still be in the denominator in your answer. Now, I call this is kind of a special case. It's a 3-term fraction, and we're going to run into these a lot. I find that this way of simplifying actually seems more complicated to a lot of people. So again, I'm going to call this a 3-term fraction. There's another way to simplify this, which we're actually going to use a lot more than the factor method for this one special case. So I have 3 over 6x minus 9. When you're working with a 3-term fraction, another way to simplify it is to find a GCF to all 3 terms. And this really only works with 3-term fractions. So if I look at the problem as a whole, got to include everybody. So 3, 6x, and 9. Can you think of a GCF for 3, 6x, and 9? 3. So your other option, which I find is easier, is to just go through and divide each term by the GCF. So 3 divided by 3 in the numerator is 1. 6x divided by 3 is 2x. Negative 9 divided by 3 is negative 3. Same answer. And I find for this particular problem, that's usually a lot easier to see for people than to see the factor cancel. But that only applies when you have 2 terms and 1 term. And it could be flipped. The 2 terms could be in the numerator and 1 term could be in the denominator. So that's another way to solve that problem. Works just as well. So make sure you include all 3 terms. Now we're starting to get into kind of the more traditional simplified problems. I have 2 plus x over x squared minus 4. Don't try to cancel here. You can't simplify until you have factors. So when you see the direction simplify, think factor. So I want to factor. So factor the numerator, factor the denominator. Well, is there anything I can do to factor the numerator? No. It's 2 plus x. The other thing you may consider is when you have binomials that you can't factor, put them in parentheses. Because if I'm going to cancel that 2 plus x, I've got to have another 2 plus x somewhere. Good review for Friday's test. I want to factor x squared minus 4. Does anyone remember what that type of factoring is called? Perfect squares. Difference of perfect squares, to be exact. Just make sure you have subtraction if you're going to do this, which we do. So for the difference of perfect squares, am I going to see 4 anywhere in my factors? No. What number's going in those factors? You're going to have x for the x squared, and what for the 4? 2. So you're looking at your squares. What's squared? Gave you those terms. And what are my signs? Plus and minus. 1 plus, 1 minus. It's our difference of 2 perfect squares. So now that I've got this problem factored, now that I have factors, I'm free to start canceling things. Do I have any factors the same in the numerator and the denominator? X plus 2 and 2 plus x. Now they don't look exactly the same, but yes, they are identical. Because with addition, order doesn't matter. So as long as you have the same 2 things in the factors, I can cancel them. As long as it's addition. Addition is commutative, subtraction is not. And again, numerator completely canceled, what's left behind? 1. Got to leave that 1 up top, that x minus 2 is part of the denominator. So that's what we're going for in these simplified problems. You're going to factor and then cancel any factors that match. Questions? Yeah. No, nothing we do today is on the Unit 1 test. And this homework that's assigned is only for Monday. You don't have to, your focus is study. All right, D. I see x squared plus 5x plus 4 divided by x squared plus x minus 12. So the first thing people want to do is, if you don't know what you're doing, is cancel the x squared. You can't cancel terms. Cannot cancel terms. You need factors. So we've got to get some factors for the numerator and some factors for the denominator. So this is great review for your test. So I'm going to actually pull these down separately. I want to factor x squared plus 5x plus 4. 1 and 4, we're already finding a pair. So it's got 3 terms, no GCF, which means either the AC method or the shortcut. And in this particular problem, why could I use the shortcut? A is 1. I have just the x squared at the start. So once I find my pair, so AC is 1 times 4, which is 4. B is 5. I'm just looking for a pair that multiplies to 4, adds to 5. What's that pair? 1 and 4. Now, the shortcut says, build your factors. This only works if A equals 1. Each of those factors start with an x, because x times x gives me the x squared. And then those factors end with that pair, plus 1, plus 4. And I don't have to go through the grouping. If you want to go through the grouping, again, you're welcome to. I find as we get into Unit 2, people adopt the shortcut just because we have so much factoring to do. And then for the denominator, I want to factor x squared plus x minus 12. It's 3 terms again, no GCF. So either AC method or shortcut. It's what you would try. So AC is 1 times negative 12 is negative 12. And B is 1. So I need a pair that multiplies to negative 12, adds up to positive 1. Rob? Positive 4, negative 3. And if you want, you can go through all the grouping. But I can tell you right now what your factors are going to end at. You're going to have x plus 4, that's the positive 4, and then x minus 3. So once you find that pair, as long as A is 1, as long as you start with just x squared, you can go right to your factors. And now that I have my factors, I'm free to cancel. But you have to have factors first. So what in this problem can I cancel out? X plus 4. If it occurs in both the numerator and the denominator, we can cancel it. So I'm left with x plus 1 over x minus 3. And that's as far as I can go because I'm back to terms now. Back to terms. So again, this is not on your tests. Factoring, absolutely, all over your test. So any questions on just factor? If they match, we can cancel them. So there's one more concept that goes with this simplifying. And we're going to start out with numerical examples to see kind of how this works. So my first example here is I have 3 minus 1 divided by 1 minus 3. So what's 3 minus 1? 3 minus 1? 2. How about 1 minus 3? Negative 2. And what's 2 divided by negative 2? Negative 1. All right, next, I have 5 minus 9 over 9 minus 5. So what's 5 minus 9? Negative 4. And 9 minus 5? 4. And if I divide them, I get negative 1. Now, notice, if we were thinking about these in terms of factors, so let's pretend they looked like factors. What's the same about them? What's different? These aren't the exact same. There's one key difference. They're both subtraction. The numbers are switched. So the numbers are switched. Other than that, they look the same. And notice that they are both, this is another key here, both subtraction. This creates what we call opposites. Opposites are factors that are both subtraction but the order of terms is reversed. They still cancel. But when you cancel, you leave a -1. And it can be in the numerator or the denominator. That does not matter. I'll always put mine in the numerator. Doesn't matter where you put that. It just leaves a -1. So if I look at G, do you have a question? No, it's not just the one. See, this one doesn't have ones in it, and it still works out to a -1. If I'm looking at my problem, so these are binomials that can't be factored. So notice, they both have x, they both have 3. They're both subtracted, but one of them's flipped around. 3 minus x, x minus 3. These will cancel, but they leave a -1. And I'll show you why. I don't expect you to be able to reproduce the y for the algebra ones, just to know that they cancel to a -1, that they're opposites. So you got to kind of follow me. This is how a lot of kind of proofs work. So I'm going to go ahead. This is the y. I'm going to go ahead and I'm going to switch the order of the denominator. Does everyone agree that 3 minus x is the same as -x plus 3? But the x is negative, the 3 is positive. Okay, now what could I factor out of the denominator? Because I don't want the x to be negative. I like that leading term to be positive. What could I, if I wanted to, factor out of the denominator? -1. Okay, so let's just keep going down Crazy Street. If I factor a -1 out of the denominator, it's out front, and that's going to make x minus 3. Again, not something I expect you to be able to reproduce. But this is just why it works. Well, if I look at this now, can I cancel any of my factors? Yeah, what can I cancel? The x minus 3's cancel. And when the numerator gets completely crossed out, what goes in its place? The numerator, just by itself, is going to be +1. So I'm down to 1 over -1, just -1. That's the whole reason why opposites cancel to a -1. What I need you to recognize is just when you have opposites, not necessarily going through the factor out a negative, but that if you have the same two terms in your factors, they're both subtraction, but one's turned around, you can cancel them, but they leave a -1. And we'll do some examples with that. So how about h? X plus 7 over 7 plus x. Can I simplify it? Okay, simplify. And if you want to see them as factors, since they're binomials, x plus 7 over 7 plus x. Can I simplify them? We've got some no's. Look back at C. Could I simplify 2 plus x over x plus 2? We did. Let me ask you this question. Let's make an aside. What if I have 3 plus 5 over 5 plus 3? What's 3 plus 5? 8. What's 5 plus 3? 8. And 8 divided by 8? 1. So if I have a factor, they're both addition. Order doesn't matter. The point of putting this one here is that order doesn't matter. If they're both addition, I can cancel them. The only time I get this kind of special case -1 is if they're both subtraction and one is flipped around. So if you look back at C, the order doesn't matter for addition. As long as it's got the same terms in the factor, I can cancel it. Say it again? Yes, if they match and they're if they're both positive, order doesn't matter. It's always going to be a positive one. The only time you get a negative one is this special case right here. Yeah.
Are you just dividing basically? Because the -3, you're dividing that. That's what you want.
That's not how it works. It's really through this process. Yeah, because when you do that, you're trying to cancel terms now, not factors. So if it's addition, the order doesn't matter. They always leave a positive one, no matter what. If it's subtraction and they're flipped around, you get a negative one. How about this one right here? X plus 10 over x minus 10. Thoughts? Mixing it now. So your options are positive 1, negative 1, or maybe you can't do anything. Does this meet the criteria for G? Both subtraction orders reversed. No. What's not true here? They're not both subtraction, not opposites. For opposites, both have to be subtraction. This one I can't be simplified. First thing, to be able to simplify, they have to have the same sign. Both subtraction or both addition. If you have one of each, you have no chance. This one cannot be simplified. And let's put our idea of opposites actually into a problem now and see maybe if it makes a little bit more sense than these single factors here. All right, J. I have 9 minus 15x over 5x squared minus 3x. So the directions are simplify, which means you need to factor the numerator, factor the denominator, and see if there's things you can cancel. So I want to factor 9 minus 15x. How am I going to factor that? GCF. Whenever you're factoring, first thing to do is look for a GCF. So I can factor out a 3, which leaves me with 3 minus 5x. How about 5x squared minus 3x? When you're asked to factor, what's the first thing you should look for? GCF. What's my greatest common factor here? X. Factor out an x. That's going to leave me with 5x minus 3. Now notice, these factors look almost identical, except one of them's flipped around, which if it was addition wouldn't matter, but with subtraction it matters. This is your case of opposites. They're both subtraction, but the order in one is flipped. I can still cancel them, but when I have opposites, what's left behind? Negative 1. I'm going to be multiplying by a negative 1. Now, numerator or denominator does not matter. You just got to put it one or the other. So my numerator is 3 times negative 1. I have that negative because they were opposites is negative 3. All that's left in my denominator is x. Again, if you had 3 over negative x, it's the same. Or in your book, you'd probably see the negative sign out front. Those are all the same. But that's what it looks like when it appears in a problem. And then I'm going to factor this last one for us just because we're getting short on time. Again, you'd use the shortcut. A pair that multiplies to 12 adds to negative 7. It's going to be y minus 3, y minus 4 over 3 minus y, which since I can't factor it, it's a binomial, put it in parentheses so it looks like a factor. You've got to cancel the whole thing or nothing at all. So what could I cancel here? Y minus 3 and 3 minus y. But do they match exactly? No. The order matters when you have subtraction. But other than that, they look pretty close. These are our opposites, which means I can cancel them, but what's left behind? Negative 1. So it's negative 1 times y minus 4, which if you distribute is negative y plus 4. So we're out of time. We'll finish L on Monday.